You reach into your pocket, pull out your phone, tap a totally flat piece of glass, and literally instantly, the whole world opens up. You're suddenly FaceTiming a friend halfway across the globe, or checking your bank balance, or streaming a movie in 4K. We all do it dozens, maybe hundreds of times a day, without even giving it a second thought. But think about it. What is actually happening right behind that screen? What unseen forces are springing into action the exact millisecond your finger makes contact?
Well, welcome to today's Explainer, where we're demystifying iOS, the anatomy of a tap. Today, we're going to pull back the curtain together and reveal the incredibly intricate software architecture of iOS that makes this everyday magic possible. I am so excited to guide you through this because honestly, once you understand what's really happening under the hood, you'll absolutely never look at your device the same way again.
Here's our roadmap for today. We'll start with 1. The magic under the glass. Then dive into 2. The brains, hardware and kernel. Explore 3. Keeping it safe, sandboxing. Take a look at 4. Managing the chaos, memory. And finally zoom all the way out to 5. Beyond the device, iCloud.
All right, let's jump right in. Section 1. The magic under the glass. Think back to 2007. The original iPhone OS was super clean, simple, and frankly, revolutionary for its time. But look at modern iOS today. It is packed with widgets, real-time data, complex designs. This contrast really perfectly illustrates just how far the software layer has evolved. I mean, what started out as a fairly straightforward way to manage phone calls and act as a digital iPod has completely transformed into an incredibly robust brain. And this brain powers hundreds of millions of devices worldwide, constantly coordinating everything from minute battery management to heavy-duty wireless communications.
To really appreciate what we're holding in our hands right now, we kind of have to look at how we got here. Every major update built a crucial piece of the foundation. Back in 2007, we got the multi-touch interface. Then the App Store followed in 2008, which fundamentally changed how we even use software. 2010 brought us multitasking. 2013 was the massive visual redesign. Then we leaped forward to home screen widgets in 2020, and now all the way up to the advanced AI and customization features of 2024. So every single tap you make today relies entirely on this decades-long accumulation of brilliant engineering.
But let's bring it back to the present moment. Our journey today, the anatomy of a tap, begins right here. Just a finger meeting a screen. It feels like a purely physical interaction, right? But it's actually the spark that ignites a massive, sprawling chain reaction.
Here is exactly what goes down. When your finger touches that capacitive touchscreen, you literally alter its electrical field. You're actually drawing away a tiny bit of charge. Instantly, microscopic sensors detect the exact precise location of that change. iOS jumps right in, interprets the gesture, figuring out, okay, is this a tap, a swipe, a pinch, a long press, and then the screen responds. And the craziest part? All this happens instantly.
Which brings us to Section 2, the brains, hardware and kernel.
Just beneath that glass is what I like to think of as a wildly dense, highly complex city of components. We're talking RAM, storage, cameras, speakers, cellular radios, and batteries, all packed in there. Now, iOS doesn't just sit politely on top of this hardware, it has to communicate directly with every single one of those components through a web of intricate software drivers. It is the ultimate coordinator of this tiny city.
And right at the absolute center of that physical city is the processor, the Apple Silicon chip. This is where the heavy lifting actually occurs. When your tap says, hey, open this app, the physical crunching of those numbers happens right here, entirely driven and directed by the operating system.
So you might be wondering what part of the operating system is giving the actual orders. Think of the XNU kernel as the invisible conductor of a massive, frantic orchestra. It lives at the absolute heart of iOS. It dictates memory allocation, schedules the CPU's time, handles the hardware communication, and enforces system security. It is making the ultimate split-second decisions about which apps get the processor's attention at any given microsecond. It does all of this to ensure everything runs buttery smooth and no two apps trip over each other. But that brings up a great question. How does iOS keep your personal data private in the midst of all this constant coordination?
That takes us to Section 3, keeping it safe, sandboxing. One of the absolute most important security features in iOS is something called app sandboxing. Imagine every single app you download lives in its own impenetrable walled garden. It's Sandbox. An app is completely isolated from all the others. What this means in practice is that a simple Notes app cannot just peek over the wall and view the highly sensitive data inside your banking app. It's totally walled off. This prevents unauthorized data access, it drastically limits the spread of any potential malware, and it massively increases the overall stability of the system.
But iOS actually goes even further. What about your most sensitive data? Stuff like your fingerprint or your Face ID? Well, this is where the Secure Enclave comes in. The Secure Enclave is a dedicated, highly advanced digital vault, physically separated from the rest of the system. It stores your biometric data, your encryption keys, and your Apple Pay info. It is so tightly isolated that even if the main operating system were somehow entirely compromised, the data locked inside the Secure Enclave remains protected. Furthermore, your Face ID and Touch ID information is literally never sent to Apple's servers. It stays right there, fully encrypted on your device.
Let's move on to Section 4, Managing the Chaos, Memory. Okay, so when you tap an app icon, a rapid-fire sequence kicks off. First, iOS loads the app into memory. Second, the processor starts executing the code. Third, system resources are heavily allocated. And finally, fourth, the graphical interface actually appears on your screen. This sequence feels like pure magic, but it is intense, heavy computational work happening in literally a fraction of a second. But here is a situation I know we can all relate to. What happens when you have, say, 30 Safari tabs open, plus a dozen apps running in the background, and your phone starts running out of memory? It's a huge, invisible problem that the OS has to handle constantly, usually without you even noticing a hiccup.
To keep your device feeling fast and to save your battery life, iOS acts as a notoriously ruthless cleaner. When memory gets scarce, the system automatically steps in. It suspends those background apps so they essentially freeze in place. It clears out cache data that just isn't actively needed right now, and it completely terminates unused processes. This invisible cleanup crew is exactly why you can have 50 apps installed and technically open, but your phone still responds instantly to your touch.
Finally, Section 5, Beyond the Device, iCloud.
Because let's be real, our tap doesn't just live on the phone anymore. Through various system services, iOS connects far beyond the physical hardware in your hand. When you create a new file, or save a contact, or take a quick photo, tiny background worker programs, which are known as iCloud daemons, instantly synchronize that data up to the cloud and shoot it right back down to all your other devices. If you change a password on your iPhone, it's immediately updated on your laptop. It's seamless. To make all this cloud integration possible, iOS is constantly managing a massive array of wireless technologies. It is relentlessly juggling Wi-Fi, Bluetooth, cellular networks, AirDrop, your personal hotspot, NFC for mobile payments, and hey, even satellite features on the newer models. Plus, it's continuously monitoring for software updates that are delivered silently over the air just to ensure your security is fully patched and you always have the latest features. It's this continuous, completely invisible dialogue happening between your phone and the entire connected world.
Which brings us to the end of our explainer today. We've traced the journey from that tiny electrical charge on your fingertip down into the microscopic XNU kernel, right through the fortified Secure Enclave, and all the way out into the sprawling global iCloud network. So I want to leave you with this thought. Next time you reach out and tap that glass, ask yourself, are you just opening an app, or are you commanding a vast invisible symphony? Thank you so much for exploring this with me today, and as always, stay curious.